We can figure out definite integrals using the formulas we have for antiderivatives and the fundamental theorem of calculus. Remember what the fundamental theorem of calculus tells us. The integral from a to b of f of x dx is capital F of b minus capital F of a, where capital F is a function so that capital F prime of x is equal to little f of x. That is, if we can find the antiderivative of the integrand, we can use this formula to figure out the value of the definite integral. Well, now we have a way of finding a formula for the antiderivative of an integrand. If the integrand is something like x to the n, then we can find a formula for the antiderivative using this x to the n plus 1 over n plus 1 plus a constant. So this is the most general antiderivative. So we can combine these two facts together to allow us to evaluate a lot of different definite integrals. Let's see how it works. Suppose we want to integrate from 1 to 2 of x to the 4th dx. Well, in this case, we can identify what f of x is. F of x is this integrand, x to the 4th. And now we can use this rule to figure out what an antiderivative is. What's the antiderivative of x to the 4th? Well, in this case, n equals 4. We add 1 to 4 to get 5, so it's x to the 5th over 5. And the most general antiderivative is going to be x to the 5th over 5 plus a constant. Now we can use this rule to figure out what the integral is. So the integral from 1 to 2 of x to the 4th dx is going to be in terms of this. And the nice thing about the fundamental theorem of calculus here is we don't have to worry about the plus c. Because if we kept the plus c in, it would cancel out. It would be on both sides here, and it would just drop out. This works. The fundamental theorem of calculus tells us this works no matter which antiderivative we choose. So we'll just choose x to the 5th over 5 and ignore the plus c. And we'll always get the right answer. And the notation we use to keep track of what we're doing is we write down x to the 5th over 5 to indicate x to the 5th over 5 is an antiderivative of x to the 4th. But we have to apply this formula to it. That is, we have to evaluate it at 2 and then subtract what we get when we evaluate it at 1. So the 1s and the 2s just come over here. We put a vertical bar and we write it on the other side. And this notation tells us what to do next. The next thing to do is to plug 2 into x to the 5th over 5 to get 2 to the 5th over 5. And then subtract what we get when we plug 1 into x to the 5th over 5. We get 1 to the 5th over 5. We've used this formula exactly, and we've introduced a notation to help keep track of things. That is, capital F of x is going to be x to the 5th over 5. We put in 2. We put in this 2 to capital F. We get 2 to the 5th over 5. That's f of b. Then we subtract off f of a. In this case, a is 1. We put in 1 for f of x. We get 1 to the 5th over 5 when we subtract. We can simplify. 2 to the 5th is 32. 32 minus 1 is 31. So we get 31 over 35. Let's look at another example. For the next example, let's look at the integral from minus 1 to 2 of x squared dx. Again, the function is going to be x squared. We need to figure out an antiderivative. An antiderivative of x squared, the most general one, is x cubed over 3 plus a constant. Again, we get to ignore the constant. And the way this will work out is now we integrate from minus 1 to 2 of x squared dx. Using our notation, the general antiderivative of x squared is x cubed over 3. We're going to evaluate that between minus 1 and 2. That's going to give us capital F of b minus capital F of a. So capital F of b is 2 cubed over 3, if we just use the x cubed over 3. Capital F of a is minus 1 cubed over 3, if we just use the capital F of a. And then we just simplify this expression, and we end up with 9/3, which is, of course, equal to 3. So this is a way we can use antiderivatives in conjunction with the fundamental theorem of calculus to help us find definite integrals. And notice that this notation that we have on the bottom line is very compact. That is, we can do everything just on this one line. We think x to the 4th, we think the formula, we write x to the 5th over 5, and then we just write down 2 to the 5th over 5 minus 1 to the 5th over 5 is equal to 31 over 5. So this notation allows us to write down the answer or the solution, the complete solution to this problem, all on one line. And that's very convenient, and it's a very powerful way of actually figuring out values of definite integrals.